Watch how a convolutional neural network, the computational model used for facial and object recognition, identifies a cat from a pile of raw data. The machine has absolutely no comprehension of what a feline actually is. It doesn't understand biology, fur, or the essence of an animal. It operates entirely through mathematical exclusion. To find the cat, the system calculates and deletes the pixel patterns that match a dog, a car, or a bird. It identifies reality by subtracting everything that is not the target. Modern machine learning defines an object not by what it is, but by everything it isn't. This method of learning through systematic exclusion was formulated 1,500 years ago in the university halls of ancient India. A 5th-century Buddhist monk named Dignaga developed an epistemological framework called Hetu Vidya, or the science of reasons. He built it to standardize philosophical debate. To defend his philosophy, Dignaga had to solve a specific problem: how to categorize the world accurately without relying on the concept of an eternal soul or a fixed essence in objects. In the West, logic followed the standards set by Aristotle. He championed the top-down deductive syllogism, moving from general rule to specific conclusion. For Buddhist logicians, this top-down approach was too abstract. It functioned like a math equation that could be logically perfect while remaining completely detached from physical observation. This document outlines the Buddhists' three-branch argument, an evidence-based alternative to the Greek system. Dignaga added a requirement called the example. Look at the lower section. Speakers had to provide a physical instance, a similar or dissimilar example, to ground logic in reality. While Greek logic prioritized the formal consistency of the formula, Buddhist logic demanded that every conclusion be verified by empirical instances in the world. This empirical focus led to a fundamental question. If nothing has an eternal, fixed essence, why do humans universally agree on categories? Dignaga proposed a theory called apova, or exclusion. He argued that words and categories do not signify a positive, inherent quality in things. When we label a cow, we aren't identifying a metaphysical cowness. Instead, our minds draw boundaries that exclude all non-cows. We recognize the object simply because it is a non-cow. Human categorization is a useful illusion. We navigate the world by defining what things are not, rather than what they ultimately are. This logic reflects the internal weighted layers of a deep neural network. It begins with chaotic sensory data, what Dignaga called the ultimate truth, and processes it through statistical regularities. The final output layer then assigns a static, agreed-upon label, a conventional truth that allows the machine to function. When an AI identifies a cat, it is demonstrating the Buddhist principle that a label is just a pragmatic summary of statistical exclusions. This isn't just a historical curiosity. Organizations like the Mind and Life Institute have spent decades facilitating active collaborations between neuroscientists and Buddhist scholars. Francisco Varela, a pioneer in cognitive science, proposed that studying the brain's biology requires a complement: the centuries of systematic first-person observations of human experience preserved in the Buddhist tradition. By treating experience as an empirical science, this tradition has documented how basic biobehavioral functions, once thought to be fixed, can be changed through targeted training. You can apply Dignaga's logic of exclusion to your own psychology. Think of a rigid anxiety or a flash of anger you felt today. We often treat these emotions as essential parts of who we are, a process called cognitive reification. But Dignaga's logic shows that these feelings have no fixed, eternal essence. Because these emotional identities are just temporary labels built by excluding other states, the mental habits that produce them are capable of plastic transformation. Whether it is your phone's facial recognition or your own self-perception, the way we understand our reality is governed by a 1,500-year-old science of reasons.